All right, so on to the second part of 6.03, we're going to go over unit vector. And the formula's here, but just in case you want to check your answer, the magnitude of a unit vector or the length of the unit vector will always equal to 1. So note in the example that they ask for the unit vector of a vector that's already solved in component form. You can tell with these triangular brackets, -2, 5. So I'm just going to apply this to the actual unit vector formula. So I know they named some vectors u, but I'm just going to label this u for unit vector equals the vector given over the magnitude of the vector. So the vector given is going to be -2, 5. And to find the magnitude of it, I'm going to take a sidebar and I'm going to take the square root of -2 squared plus 5 squared. So that will give me 4 plus 25. So the magnitude is the square root of 29. So going back to the formula, I'm going to rewrite this as the square root of 29. And finally, for the unit vector, I'm just going to place the x component over the square root of 29 and the y component over the square root of 29. And that will be my unit vector. Now, I know that a lot of you just want to rationalize this denominator, but on a unit vector, just leave it alone because when you, in this case, verify the result of the unit vector has a length of 1, it just makes life easier. So I'm going to verify that the result of the unit vector has a magnitude or length of 1. So I'm going to take each one and square it. So the square root of -2 over square root of 29 squared plus 5 over square root of 29 squared. And that would give me, whenever I square a fraction, I square each one individually, -2 squared would give me 4. And the square root of 29 squared, squared and square roots get rid of each other. So that just leaves you with 29 plus 5 squared, which is 25, over, again, square root of 29 squared. Square and square roots get rid of each other, leaving you with 29. Now, yes, you can do crisscross applesauce, but don't, because we have the same denominator when we're adding fractions. So keep it as it is and just do what the numerator says. 4 plus 25 gives me 29. 29 over 29 is 1, and the square root of 1 is 1. So this verifies that my answer for the unit vector is correct. So unit vector has a lot to do with magnitude. Make sure that you have the magnitude formula, and I went over it in the other video. The other thing that they ask for in vectors is going to be the direction angle. So for the direction angle, the first thing that I'm going to urge every one of you to do, please remember, direction angle, plot the point first. So I and j, remember in linear combination form, the I tells you the x and the j tells you the y. So in this case, and I'm just going to do a brief sketch, the x value would be 3 and the y value would be 3. So that would be the terminal point, and we assume it starts at the origin. So that's the vector. Now, why would I graph it? I just want to note actually what quadrant it's in. So remember module 4, this is quadrant 1. So to find the direction of an direction angle of a vector, we were given the formula tangent theta equals the y value over the x value. So in this case, 3 over 3. The reason why that is, I'm just going to do a quick proof for you guys, is it goes back to right triangles. Vectors do come from right triangles. So if you note, the y value is 3, the x value is also 3, and I'm looking for the angle here. And notice I'm given the opposite and adjacent side. So going back to SOHCAHTOA, opposite and adjacent uses tangent. So tangent of theta equals opposite over adjacent, 3 over 3. So because of that, this will never change. Just stating where that formula comes from. Sorry about that, my pen was acting up a little bit. So we're going to take tangent of theta equals 3 over 3. Just going to rewrite that. So tangent of theta equals opposite over adjacent, which is just 1. Now, to find the angle, tangent of theta equals to 1, I'm pretty much looking on the unit circle where tangent equals to 1. That's where I can find the angle. There's 2 angles where tangent equals to 1, which is why we graphed it first. So since we're in quadrant 1, where in quadrant 1 is tangent equal to 1? And that angle would be 45 degrees or pi over 4. And just a second example going through the same thing. You're going to graph that point first. So remember, it's 1 and negative 1. So I'm going to go over, sorry, my pen is acting up. I'm going to go over to 1 and down 1, and I should be in quadrant 4 from there. There's my vector. And to find the direction angle, again, tangent equals y over x, opposite over adjacent. So negative 1 over 1. So tangent equals to negative 1. And where does tangent equal to negative 1? In quadrant 4, that would be 315 degrees. All right, so my pen is acting up a little bit, but I hope this helps you guys.